Hey everybody, this is Larry. This is whenever today's Leetcode Day challenge. Hit the like button, subscribe, and join me on Discord. Let me know what you think about today's forum. Right now I'm in El Salvador. And now I'm in Guatemala. Yay! Alright, see ya. As you can watch from here, actually, this is as fast as the drone goes. The drone goes up to about 40 miles per hour. And yeah. And this is as fast as it can go. That's how much wind there is. I can't even go past like a few feet. So I'm just glad I didn't lose my drone. All right, back to Future Larry. Hey everybody, this is Larry. This is, oh yeah, I already did the intro, but it's day 20 of the Leetcode Day Challenge. I think day 21? 21st? Okay, day 21st of the Leetcode Day Challenge. Apparently I'm just wrong a lot. I hope you liked the intro. I am now back in Santa Ana in El Salvador, just resting. It was a very long day. And then, honestly, driving was the hard part, just in general, is very, just very intense. But yeah, let's take a look at today's farm. Day 21. My internet is not as fast as I would like here in Santa Ana, but as you can see, alrighty, behave. Let's see. Technology, how does this work? I'm doing anything with it. I don't think I'm doing anything, I don't know. I don't think so. I don't know why it's so slow, honestly. Alright, anyway, maybe Leetcode's doing something weird. I'm gonna blame it on Leetcode for now. But yeah, today we have a hard problem, which is great because I like hard problems, even when I want to, sleep. I'm just thinking real quick when the admin of code is, I'm like an hour off I am usually, so yeah. Anyway, today we have 2872 maximum number of K-Divisible components. Yeah. There's an undirected tree and nodes, okay, edges, okay, what's the question? There's a value on each node, the value split we will probably do such that we sell in components or okay. I think the first thing to notice is that first, the entire sum has to be divisible by k, right? Because, well, yeah. Okay, so then that seems to be true with the constraints. And that means that any split, as long as you don't kind of separate things out, yeah, as long as you don't separate things out, that invariant will always be true, right? What I mean by that is if you do only one split at a time, maybe taking so that like you only take a subtree at a time, right? Then what does that mean? If you do a subtree at a time, then you have two components, meaning if you split one component into two components, and that's what I mean by subtree, maybe that's another way of saying it. In that case, then both components would be divisible by k, right? Meaning if one component is divisible by k, then the other one will be as well. So then now, I think in a greedy way, anytime a subtree can be split by this rule of a component being able to have the value of k, then we just do it again, right? Or we do it every time that we can because it doesn't change the uppercase, right? Because if you kind of go from the leaf up, you remove a subtree is divisible by k, then all the stuff that is parent to that k, actually that doesn't change anything, right? Because you get another way to think about it is that because if that's divisible by k, then it means it's 0. 0 is the remainder, and that means that it doesn't affect the rest of it, right? So you could keep on doing it as much as you want. I think that's really it. I think my initial idea question after that is that you know, does it matter which number we root the tree? And I don't think so in general, because we're just taking trees from the leaf, and what's remaining will be the one anyway, right? Because you, as we said, this is one of the invariants, so I think we should be good. So here maybe we can just first convert it to an adjacency list, and then now for UV in edges, okay, and then now we just maybe, you know, just I don't know, just go traverse. It's not a good name, but it is what it is, right? I'm just okay, so you have a node. I'm trying to think what we should return. What should traverse do? I think it should return. I think one thing that I make a mistake sometimes is that it's okay to return two things. It's a little bit annoying, it's a little bit confusing, but it's okay. And here I want to two things. One is the subtree sum, and then maybe the number of components that we already did. I think this one in theory you could also use global, like a global variable or a non-local variable in this case, but either one should be fine, right? But yeah. Yeah, and in here, if notice none, which I don't think I ever should unless the entire tree has 0 nodes. Oh, yeah, of 0 nodes. I don't think this is possible. Otherwise, then now for I guess because this is a tree, you just have parent so that so we don't go up, right? Otherwise, then now we have, you know, subtree sum, maybe this. We have number of components is equal to traverse v, right? And then we have a total of these. So there are two things we can do. One is, yeah, I mean, naming things is just hard, you know. Whatever, total. Total. This is terrible. Right. Yeah. And then we just, I don't know, just write it out. I can't even spell that. Right. And I think that should be roughly right. We have to kind of we add it to the nodes of the current node, and number of components don't change yet, which is that yeah, if this is mod k is equal to 0, then we just add 1 to this, and that should be good, I think. And then now we can yeah, I think now we should be good, and we can just take any node that is 0 indexed, okay? And oh, well, this returns two things, so yeah, so we don't care about the sum, or I mean, no, it should be okay. Requires precision. Oh, I forgot to do parent. Whoops. No. Do I keep going? Recency list of is not equal to parent. Some days I just don't know. Like I feel like other things can happen, but infinite loop is kind of weird. Is it infinite loop? This is only 1,000. Did Leetcode screw up something with number of recursion stuff again? This is 30,000, so maybe we need to. I forget how to do it. Python increase recursion limit. I forget what it doesn't really come up that much. I just Google it. Maybe I should have asked ChatGPT about it. But yeah. Maybe I should have because this is silly. But okay. I don't know. It's going to set a big number. It's fine. Right? But now if it recurs out, then we know. I don't know. Okay. Yeah. So maybe I do have other issues. Do I have other issues? Maybe. What is going on now? Now, how is this? Like, am I messing something up? But like it doesn't go. We know. Huh? I'm so confused, honestly. Okay, let's get rid of this for now. I mean, because Leetcode has it, but what am I doing wrong? Two zero, but why would it go to 0? Parent is. What is this? Larry, are you dumb? Okay. I mean, I was staring at it. I don't know. I wish I had a good thing to tell you, but I am a silly boy. Also, I forget to I said that we would return 2 things, and I just returned 1 thing anyway. So yeah, a lot of silly mistakes. But as you can see, I feel like my algo's been okay, but maybe not, honestly. But the implementation's have been poor these days. But yeah, let's give it a quick submit, and yeah, there we go. Yeah, with those things in mind, you can with the invariance, this becomes a little bit easier, right? And the complexity, just linear time, linear space, right? So pretty good, pretty Gucci. Yeah, and I think the trick thing is realizing this invariant, and once you kind of like explore what that means, then everything kind of fits together, and the code kind of looks a little bit wonky if you don't understand it. And even if you do understand it, apparently, because I make silly mistakes, even though I've written this 1,000 times. But yeah, that's all I have for this one. As you can see, I was a long day, so yeah. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.